Building software has become a common practice for almost all medium to large businesses out there. The increasing number of websites and mobile applications, as well as the growing number of software companies in the world, may suggest that building software is an easy endeavor, but this is not the case. A report released in 2016 by the Austrian software testing company Tricentis estimated that the total cost of software bugs, glitches and security failures worldwide was roughly $1.1 trillion. For some perspective, that is more than the total gross domestic product of Mexico in the same year. Reviewing more than 500 software failures mentioned in English-language news articles, the report shows that software failures affected more than 4.4 billion customers and caused more than 315 years of lost time. Time which software companies had to pay for, in one way or another. In order to understand how software issues influence profitability, consider a software application for which loading times are too high, that does not protect personal data, or, for which basic functionality, like saving your work, is broken. No one would ever use such an application. As such, it is in any company's best interest to produce software with as few issues as possible, in order to maintain profitability. Aside from human error, the most common causes that lead to software issues are incorrect or inexact knowledge of the used programming languages. In most companies, the amount of work and the need to remain profitable may lead to hiring of junior developers and then giving these people complex tasks which are above their level of expertise. The lower the experience, the more difficulty developers have in understanding other people's code, leading to time spent mostly on reading and understanding code instead of working on their tasks. Lack of knowledge of development practices and principles. These are meant to keep the codebase easy to understand and maintain. The lack of these practices and principles usually leads to bad implementations that take longer than they actually should. Having these practices in place, especially unit testing and code review, also prevents the introduction of new issues in the codebase, which may occur due to the pressure to deliver, or, in some cases, the lack of focus or involvement of the developers. Constant changes of developers working on a product. Some people leave, get promoted or get bored and ask to change projects. This means that other people with no business or codebase knowledge will start working on existing code. They need to go through the code and understand what it does in order to know how to change or extend it. Multiple teams, from multiple locations, work on the same software application. Lack of communication and standardization favors incorrect implementations or interpretations of the requirements, leading to unwanted or incorrect behavior of the application. People share their code, but other teams need to understand what it does before they can start working with it. Features constantly get updated, improved or changed as a result of feedback from clients, stakeholders and QA. Any software application usually produces a profit after at least a few versions are released. As such, the codebase needs to be easy to change and test, so that updates do not introduce issues to new or existing functionality. As you can see, all these causes for software issues revolve around working with code. It turns out that on average, developers spend between 60% and 80% of their time reading, searching or modifying code. Various studies dating back to the early 90s show that this situation has not improved over time, and companies are still faced with the same problem. To solve, or improve the problem of working with shared code, over time, developers need to write code that is correct, adheres to all standards and principles and is very easy to understand. Unfortunately, in practice, most developers write code that is exactly the opposite. We call this bad code. The cost of dealing with bad code is estimated to be as high as $85 billion per year, across all software companies. On average, out of a normal work week, 45% of the time is spent on reading and understanding code, 30% is spent on rewriting code, and only 25% is spent on the actual implementation of tasks. In order to directly improve code quality and the software delivery process, we will learn a set of practices that ensure that the code we write is good. These practices, named clean code, have first been introduced by Robert C. Martin in his book, Clean Code, A Handbook of Agile Software Craftsmanship, in 2008. Since then they have been updated and adjusted for modern frameworks and programming languages and, widely adopted by successful software companies all around the world as core practices for writing code. As software developers, we want to ensure that the code we write enables other developers to maintain and extend it, with minimal invested time and a minimal risk of causing unwanted behaviors. As such, the purpose of clean code practices is to provide standardization, which means that every developer adheres to the same rules and practices, making the code easier to understand, evaluate, test and review. Readability. Code is easier to understand and change because it is more readable. Names are self-explanatory, reveal intent and are searchable. Simplicity. Code is easier to test, change and maintain due to reduced complexity and cohesion of its comprising parts. Consistency. Everyone writes code in a similar, familiar way, making it easier to bring people on board, or even share code with other teams or partners. Changing from one project with clean code to another with the same practices is easier, as the quality of the code is consistent. Cost-effective. Well, mostly due to all the advantages already mentioned. Clean code practices are meant to simplify the codebase, to make it more flexible and easier to work on, reducing the risk of bugs being introduced and making the code easier to test. In terms of semantics, clean code can be compared to the set of grammatical rules for any programming language, describing what structures go well together, how code should be structured and used, how to correctly define behavior, and what constructs do not belong together, as they may be confusing or incorrect. In this course, we will discuss all the practices, principles, rules and laws encapsulated in the modern concept of clean code. The knowledge you will gain from this course will ensure delivery of high-quality code, faster development times and lower delivery costs. We will get a detailed look at the most effective and the most problematic practices when writing code. Finally, we will analyze code samples that show how code should be written and what problems should be avoided at all costs. At the end of this course you are going to be able to write readable, searchable, maintainable and easily testable clean code.